Hello and welcome to this IMO GloFouling project webinar. This month it's on understanding ultrasonic anti-fouling with myself, Darren Jones, who happens to be the chair of the IMO's GloFouling GIA and a director of Sonihull, and I'm joined by Dr. Mark Potter. Mark, do you want to introduce yourself?
Hi everyone, thank you Darren. As Darren said, I'm Dr. Mark Potter, visiting academic at the University of Warwick Department of Physics, home at the Centre for Industrial Ultrasonics. I'm also the director of Sonemat.
And hopefully the two of us today will be able to show you and give you a little understanding of how ultrasonic anti-fouling works and why it works in the marine industry and marine setting. Now, clearly everybody listening to this webinar will be well aware of the effects of biofouling, but it's really important never to miss an opportunity to hammer home the real problems to our environment and to our operations that biofouling causes. And the GloFouling project really does focus on the risk of invasive species, what that does to our environment, but also as operators, we don't want to be seeing our vessels be turned away from ports. And then of course there's fuel efficiency, the cost of that fuel and the drag and the inefficiency from propellers and hulls, but also the greenhouse gases. And of course that focus on CO2 at the moment has never been higher. And then the other stressor is the pollution from toxins entering our seas, biocides, heavy metals and residues from coatings. Whilst we see fantastic work done by the coatings companies, nevertheless we all, including themselves, try to do more about that. And these are some of the areas that ultrasonics really does come into its own. So what is being done to address the biofouling issue? Well, as you can see, a whole selection of underwater structures. It's not just vessels, but on vessels in particular, you can see we've done out of water cleaning in dry docks, fellow there on a smaller vessel, and today we do in water cleaning, quite often not just using divers, but using robots. And where we use those robotic and ROVs, there are issues with niche areas, and there have always been, even with divers, issues with niche areas. I think you can see in the bottom left-hand corner the grill to a cooling system, and inside these cooling systems has always been a problem to address. And we've used things like ICAF systems with limited effect, and these are areas where really ultrasonics can come into its own. And of course there is still the use of coatings. We will always paint our vessels. How much biocide is in that and what the makeup of that biocide is, what is changing due to regulation and due just to all of us not wanting to pollute our oceans. And I have to say, hats off to the coatings manufacturers. They're doing a great job at coming up with some new alternatives. But of course there is a cost implication, an efficacy implication, and how long does it last and how hard wearing is it, that we all have to work together with various technologies, be it the cleaning technologies, be it the preventative technologies such as ultrasound or those coatings companies. In order to really understand the effect of ultrasonics on biofouling, it's important just to go back to basics on what biofouling is and how it's created. So the first stage is the creation of that marine biofilm. Those bacterial cells settle onto that hard surface. The cells propagate, secrete residue and form that biofilm. Some cells detach, but then other bacteria and higher forms of organism attach, and then they grow, both attached to that organism and feeding off it. And then there's a whole food chain grows from that. And from that soft, thin biofilm, you can end up with hard crustaceans and your barnacles and your mussels and all other sorts of nasties that we know create drag and corrosion on our vessels and also spread themselves to parts of the world where they really do not belong.
So, in terms of the science behind ultrasonic anti-fouling, the transducer, usually piezoelectric or magnetostrictive, sends fairly low frequency ultrasound, which is about 20 to 60 kilohertz typically, into the metal or other material of the hull, pipe or region you want to protect. These sound waves travel through the solid material and spread out, increasing the area covered and re-radiating from edges such as propeller blades to spread the energy to hard to reach places. Then the energy is transmitted into the water where it causes what we call non-inertial cavitation. Many of you will know about its big bad cousin, inertial cavitation, where a sudden lowering of pressure in a region of liquid, usually due to mechanical motion such as a propeller blade, causes the water to vaporize, making a bubble that's very unstable and full of energy. It collapses, causing a massive shock wave that can wear away metal as well as killing organic matter nearby. But in non-inertial cavitation, the bubble is more stable. It doesn't violently collapse, it just re-radiates the energy in the area, giving enough power to kill microbial life and stop fouling from spreading without harming the nearby metal.
So there's the science, there's the how. Well, what does the kit look like? What's involved? Well, very simple, really. There's a control unit on the right there. That's a larger control unit for 8 channels, for 8 transducers, that is. And in the bottom left, you see an example of one for 2 transducers. So the equipment can be put near where it's needed, so you have a minimal transducer wire length. And as you can see in the top left there, there's your transducer. That particular one is about the size of a coffee cup. It really is very simple. Well, it looks very simple. The clever bit, of course, isn't just the music system, which is effectively what an ultrasonic system is. It's the music that it plays. So that's very important as well. But as you can see, there isn't a huge amount to it, which makes installation and maintenance very simple for ultrasonic anti-fouling. And here we see some examples of just that. Some chaps there looking at a control box, and I think on these pictures you might be able to just see down here there is a transducer on the lid of a cooling system. We've got some control boxes over here, and that is literally glued on the ring, and then that is screwed in with a little bit of grease. Another one here, and you can see that is going to be sending ultrasonic signals, another one there, through into the cooling system. These things also go on pipe work. So it's a very easy system to install, doesn't need to be dry docked, and this is one of the beauties with ultrasonics. It's actually a very simple system. Here again, we're just seeing examples on box coolers. Transducers just plopped on the top, and then there'll be, where there's access, you put them on the sides as well, and it will prevent or reduce the growth in your cooling system with very, very good results. There are thousands of these units out there in the world, and a lot of people say, oh, will ultrasonics work on my vessel? Well, it's physics. Vessels are vessels. If it's placed in the right way and it's playing the right music at great ultrasonic waves, it will reduce your growth dramatically. Now, one of the big step forwards ultrasonics has seen in the last few years, and a dramatic growth in terms of the numbers of installations, is in protecting propellers. Here you see methodology has been worked out to push those ultrasonic waves through the shaft, through the bearing and the shaft, into propellers. And we're seeing figures from I think the University of South Korea and Strathclyde, all showing that medium growth on a propeller creates 31% inefficiency. Well, the placement of this can hugely reduce that growth on the propeller. So the potential benefits are enormous, and we also know just the cost of keeping propellers clean. Well, this is now a solution that is out there, and if you're really interested in reducing your CO2, this is a very cost-effective and practical way to reduce the CO2 that's created through biofouling on your vessels. So the standard question we get is, does ultrasonics work? And the answer is yes, on thousands of installs, thousands of systems all over the world in different waters on different sorts of vessels. Here's a cooling system. No protection there. The transducers were placed only to protect this as a bit of an experiment. Everybody else has done the trials for you, folks. And as you can see, dramatic difference in growth. That was after 12 months. Not in a particularly high growth area, to be honest, but you can see this is going to be having a much better cooling effect. And these things are getting through to their 5-year docking cycle. And of course, the beauty is there's no metals being discharged into the oceans, no pollution, just cool engines. And one of the great things about ultrasonics and being part of the toolbox that we use in conjunction with other technologies to reduce the effects of biofouling is it can work on all different parts of a vessel. One of the particular areas it's very useful is in pipe work. Here is actually not that extreme, but an extreme example. On the left you can see pictures of a raw water valve on a Dutch pilot boat, and the picture on the left is what was happening every 3 months. Every 3 months, that's how much fouling it was getting. On the right you're seeing the same pipe work after 14 months using ultrasonics. Those waves are used across the pipe, and they can cover, certainly with some systems, 5 meters of pipe, depending on the dimensions of that pipe. And it's in these really critical pinch points on the pipes that are hard to clean, that involve dismantling and a lot of maintenance, that ultrasonics really comes into its own again. And often people ask, what are the effects of ultrasonics in terms of scale? Can it only be used on small vessels? Can it only be used on small pieces of a vessel? Well, clearly it can be used on whole hulls if you wish. There's an economic discussion to be had about that. But if you talk niche areas, we've seen that it can do cooling systems. Ultrasonics works on pipe work. But ultrasonics on propellers is a bit of a game changer when it comes to CO2. Here we have pictures of an 8-meter propeller, where an install on that has been protecting it and keeping it far cleaner than it would have been. We have systems across the world now on very large propellers, making an enormous difference, really reducing the number of cleans down to once every 20 months, whereas they were previously once every 3 months. And the fuel difference that makes is astonishing, as well as the performance and the reduction in wear and maintenance on engines. So as a piece of green technology, this propeller is really showing, and the propeller work is really showing the benefits of ultrasonics and the economic benefits of ultrasonics as part of the mix in biofouling prevention. So that really was a very quick presentation on what ultrasonics can do, very basic how it works, and what parts of your vessel it can work on, and also what other technologies it can work with. And for instance, it is worth just noting the new BIMCO standards on in-water cleaning, which mention that if you're going to use robotics, we're looking for 95% coverage of the underwater surfaces. Now, of course, there are certain areas where that's difficult. Again, that is where the mix of those robotics and the ultrasonics in the prevention can come in, because that ultrasonics can protect that 5% that are hard to clean with robots, and actually quite often hard to clean with divers. So as part of the mix, ultrasonics is there. So thank you for your time. Thank you for listening. I'm now delighted that I think we've got a few minutes to do a bit of a question and answer session with myself. And also I'm delighted to introduce Dr. Mark Potter, PhD, who's a director of Sonemat, who are a spin-out company partially owned by the University of Warwick and their Centre for Industrial Ultrasonics. So it's good to have someone with his level of expertise, at least,